Hi, I'm gonna see problem 2126, destroying asteroids. And in this problem, we're given a mass, and it represents the original mass of a planet. And furthermore, we have an array of asteroids where each entry in this array represents a mass of an asteroid. Now, we have to arrange this planet to collide with the asteroids in some order, and this planet will destroy any asteroid that has a mass that's less than or equal to its mass. So if the mass of the planet is greater than or equal to the mass of the asteroid, this asteroid is destroyed, and moreover the planet gains the mass of that asteroid, so it's like absorbing it. So if I have an asteroid that's 7 and my planet is 8, this will result in one big planet of mass 15, and so on. Now, if it was the opposite, if it was we had the asteroid as 8 and the planet as 7, this will destroy the planet and we will fail at this point. So we want to arrange things in a way that we always absorb the smaller asteroids of smaller mass to grow our planet and potentially destroy all the asteroids. And if we can't do that, we'll return false. If we can achieve that, then we can return true. So let's see the example which I have here. We have a planet of mass 12, and therefore it can absorb the one here, it can absorb the 11, it can absorb the 3, and it can absorb the 5, the 8, the 1. And if it goes like, if it hits 31 before absorbing the others, then it's gonna be destroyed. It's safe to assume that it's good to start absorbing everything that's smaller than our planet's mass, and afterwards we'll start moving to the one that's right after it. So this is 12, and after gaining some mass from 8, 1, 5, it's gonna be greater than 19. So hey, I'm gonna absorb 19, and then I can absorb 21 and 24 and so on. So one way to find if we can absorb these asteroids is to sort them. Any asteroid that's smaller than the mass of the planet can be absorbed. If we encounter one that's bigger, we can return false. So let's sort the array here. It will be 1, 3, 5, and here we have the array sorted in increasing order, and we have the 12 here, it's right after 11, and I can assume that I can absorb everything that's lower than 11, and afterward I'm gonna move to absorb the 19, hoping that my planet's mass is more than 19. And if we proceed in this, I'm gonna absorb 1, and this 12 will become 13, and then I'm gonna absorb 3, so this will become 16, and then I'm gonna absorb 5 to obtain 21, and therefore I know at this point that I can reach these, I can reach the 19 and 21 and take them, and so on. Now, assuming that my planet had the mass of 1 initially, I'm gonna absorb 1. This will result in 2, but then 2 will collide with 3, and things will end here. My planet will be destroyed, and I'm gonna return false. So as we saw, we can start with sorting the array of asteroids, since we're gonna move in increasing order. Since we're talking about sorting here, we have a complexity, a time complexity of O(n) log n, where n is the number of entries in asteroids. And I'm gonna increase my mass every time I encounter an asteroid. So I can enter a while loop, and as long as asteroids I is less than the current mass, I'm fine. So I can declare an integer or a counter which is initialized to 0, and while I is less than asteroids dot length, because I don't want to exceed what's in the array, and as long as the mass of the asteroids is less than the mass, I'm gonna increase the mass. So mass will absorb that asteroid, so I, and then I'm gonna increase I, so it's I++. And here, if I encounter an asteroid's I which has a mass, this is less than or equal, just to be to match the boundary conditions. But here, as long as asteroid's I is less than or equal to mass, my mass would increase, and therefore I can continue. Otherwise, I'll not enter the while loop and I would return false. Now I can write this in one statement. If I reach the end of the array, if I reach the end, which is here, if I reach this point, then I destroyed all the asteroids if I exceeded this point. So and we know that this one has an index of I equals length -1, and therefore after I exceed this last point, I would be equal to length. So if I want to know if I reach the end of this array, I just have to check if I is equal to length or not. And therefore, if I is equal to asteroids.length, it means I reached the end of the array and I can return true. Otherwise, if I didn't reach the end of the array, I will not be equal to asteroids.length. It will be less than that. This condition will not be satisfied and I'll return false. Now, instead of doing this asteroids I and then increasing I can put it in one line. So mass plus equals asteroids I++. And another thing that we have to pay attention for here is that this mass will exceed the limits of what an integer can handle. And therefore, I need to change this. So instead of using mass right away, I'm gonna declare a variable and call it current mass or car mass, and it's initialized to mass. And therefore, I'm gonna be checking against current mass, car mass, and I'm gonna increase car mass. This is a long instead of int, and therefore it can reach higher boundaries. We have a missing semicolon here, and let's submit this code. And here we get our solution. We can see that it's efficient in time and in space.